Hello, and welcome to our continuation of the discussion around computer networking. So, in this discussion, we talk about networking devices, which we had mentioned previously as being some type of device that allows you to connect two or more computers together, um, generally in a bid to share files or share some information on the computer systems, or perhaps to connect to the internet, right? Some examples of these would be hubs, switches, routers, access points, and so on and so forth, right? Now, it's possible to connect two computers together using a cable or a wireless medium without having a networking device in the middle, right? But generally, if we're going to connect three or more computers together, you're probably going to be thinking about this networking device type, right? So let's talk about routing and switching capabilities of some of these options that we have here. Let's start talking about hubs. So hubs, much like what's depicted in this picture, allow you to connect, let's say, three or more computers together. So all these guys are wired into this connecting device. Five, wired hub. That then connects to a router. Router connects to the wall using probably some Ethernet cable or DSL phone cable, depending on the type of ISP that you have. This is connected probably all the way to your ISP. The ISP gets you to the internet, right? Now, hubs are notoriously slow because they cannot send and receive data at the same time. Hence, if computer A starts sending information and computer B tries to send some information to computer A, it will need to wait till computer A is done talking before computer B can talk to computer A, right? So you cannot send and receive at the same time. That inherently makes it a little bit slower than the competition. Competition being maybe switches or routers, right? So they're generally slower. They're a little bit cheaper though. They're less complex to put together. I used to have a hub when I was in college as an undergrad, but hubs are not very popular these days, right? They tend to waste bandwidth because they tend to spam information. So if computer A is trying to send information to computer B, it's going to broadcast that information to this hub. This hub would then send the information to both of these machines, right? Saying computer A is trying to talk to somebody. I don't know who that person is because I don't have a list of your IP address. So I'm going to send that information to both computer B and computer C, right? So we're spamming the network. We're wasting a lot of bandwidth, network bandwidth, by sending the information from this guy to both of these guys. That also raises a security problem because this guy was not supposed to get that information. That was destined for this guy. But now this guy has that information. Hence, if you plug in your machine into a hub, you might be able to sniff some information that you're not supposed to have access to, right? So hubs generally have some security concerns around them. Fast forward to switches, which are a little bit smarter than hubs. They have the capability of sending and receiving data at the same time, which inherently makes them a little bit faster than hubs. They do cost a little bit more than hubs, though. They tend to identify the fact that computer A is trying to send information to computer B. And so if I know where computer B is, I would not send that same information to computer C. I'm just going to go from A to the switch. Switch goes to B. And C does not see that information. So we do improve security by using switches. They're a little bit faster because we can send and receive at the same time. Now, to be able to determine to avoid broadcasting the information from computer A to both B and C, we typically have a switching table in the middle. So you'd have some table stored inside of the switch that says computer A is trying to send information to computer B. But computer B is plugged into this interface, or this port, if you will. Not the same ports as 443 and 80. This is just where the Ethernet cable is connected on this switch device, right? So I'd have the MAC address kind of listed here. So I know computer A wants to talk to computer B. I'm not going to send the information to both C and D. I would send it to computer B. But to build this switching table, when you turn on a switch for the first time, it doesn't know where computer B is located. So what happens is computer A would send information to the switch. It would broadcast that to both B, C, and D, just like how a hub would behave. And when B responds and says, hey, that information was meant for me, I'm here on this port and I got it, then now the switching table would be built, right? So you build the MAC address. So next time A tries to send it to B, it goes to the switch. Switch says, hey, I know where B is. He's on port 6, routed there. C tries to send information to port B. It goes to the switch. Switch says, hey, I know exactly where this person is. I'm going to send it right here, right? So that's how switching tables work. Routers are an upgrade from a switch or slightly different type of connecting device. They're a little bit more expensive. They do implement network security. They have built-in security. You have some type of firewall built into your home Wi-Fi router, right? They generally communicate using Ethernet cables, kind of like the phone cable. They would have wireless in some cases. You might have a wireless router, but most of the routers are going to support generally wireless and wired. Worst case, they support just wired, but you're going to have at least a wired connection. But a lot of them would have wireless these days, right? And more than likely at your house, you have a router and probably not a switch or a hub. I used to have a hub as an undergraduate student. Not very popular these days. Almost everybody has some type of router at home, right? And sometimes your router might double up as a cable modem as well. So you might have a cable modem, which is also a router, so you don't have two separate devices. You might just have one device at home that all your computers connect to, and it in turn connects to some jack in the wall or some wireless connectivity of some sort, and then it connects to your ISP, and then you go from there to the internet, right? General concept, two or more machines connect to your router. Router and modem could be the same. Otherwise, you probably have an Ethernet cable connecting your router to the modem. You run into this in your midterm. You'd have to draw a diagram pretty close to this, but in this case, you'd have to label these. So generally, when you see this type of symbol, it means wireless. So these machines could be connecting through Ethernet or through wireless. Generally, the router to modem is going to be either one device or Ethernet. Now, where we connect into the wall here might be coaxial cable or DSL cable, phone cable of some sort, and then you're going to go from there to the ISP on the public internet, right? Access points, you can extend your Wi-Fi connectivity using wireless access points. We don't go too deep into that, but just be aware of it, that wireless access points would be another type of connecting device. Now let's dig into network classifications, right? There are several categories of networks, and it varies in the sense that there could be different types of technologies at play, different speeds of the network, how complex it is to set it up, so on and so forth. So let's talk about those briefly. So a LAN or local area network is practically what you're going to have at home, where you have some type of router, connecting device, and you've got maybe 2 or 3 computers in a contiguous or attached area. So you're in a small area at your house where your network is set up, right? Very simple network. Almost anybody can build a local area network for their house or their office with some instructions or guidance, right? Now, a wide area network would be the next level. So you think of campus, UW-Oshkosh campus, and the fact that you have a wireless network that you can connect to almost anywhere on campus. That would be a wide area network. It's wider than just your local network that you have at home, right, for connecting to the internet. It is spanning a larger geographical area, right? Wide area network. So you have the network in one building on campus is connected to another network in, another building. So we've got a network that spans, a larger area. And to build that type of network is going to take more than just Ethernet cables, right? So going from building to building, you might need a T1 line, a significantly faster internet connectivity line to connect those two buildings. So it's a slightly different technology set, and that's what a wide area network would be. The next level after that would be more of, we've got the Fox Cities area, or maybe just Appleton, or maybe just Oshkosh, and we've got a network, maybe a Wi-Fi network that you could connect to in all of Oshkosh, right? It's open to the public, so you don't have to pay for, an ISP. Maybe you just connect to this MAN, metro area network, to get onto the internet, right? There are cities that are working towards those types of solutions. Spans a significantly larger geographical area, a MAN, metro area network, right? You're not going to see that very often. The LANs and WANs you're going to see very often, especially in the school setting. The internet is just the network of networks. So when your local area network at home connects to my local area network at home, we have to be on the internet, because your network is connecting to my network. So on the internet is just internet connected networks, or interconnected networks, if you will. Another way of looking at it, right? Where you could share, photos and videos with me, and I can do the same, so on and so forth. So, taking a step back to recall what we've studied so far, we talked about ISPs and how they provide internet service. An ISP is an internet service provider. We talked about different types of mediums. It could be satellite, fiber optics, coaxial cable, as in spectrum, so on and so forth, right? DSL. We also talked about different protocols on the internet, TCP/IP. We talked about FTP, which is the file transfer protocol. But if we want to do it securely, we talked about SFTP. We talked about HTTPS, HTTP, DNS, those rules that govern how we use the internet. We talked about domain name registrar, the fact that you can, register a domain name through GoDaddy, and the organization that provides that is a domain name registrar. And of course, the ICON is the organization that manages all of that. So you can go in and purchase the domain name. We talked about top level TLD domains, domain name portion. How can you determine your public IP address? We talked about the difference between private and public IPs. Your public IP is going to be the IP address that is assigned to you by the internet service provider, as in Spectrum. Your private IP is going to be the IP address that's assigned to your machine behind the router, right? So your router at home gets an IP address, which is private, and the router has some type of firewall built into it, right? You have to type in a password to connect to that Wi-Fi, so it's a little bit secure, right? And it is using some security protocols to enforce, some level of privacy behind it. All the machines behind that router are not necessarily visible on the internet unless you're exposing a public IP. So public IP is what anybody on the public internet could see. Private IP, typically assigned by your router. Public IP is assigned by your ISP, right? So those are some key concepts to remember. Of course, we talked about e-business strategies, B2C, B2B, and some of those concepts as well. So keep in mind LANs, WANs, and MANs, the difference between those. The internet is the interconnection of networks, and do well to watch that video on how the internet works. We talked about routers, switches, and hubs. Routers are the way to go these days. This way you're going to see more often. Large organizations like your KCs and Oshkosh Trucks and Thrivent, so on and so forth, are going to have switches in their data center, right? Connecting very large computers together. Hubs you're not going to see very often these days, but they're there. We talked about IP addresses, the different types, IP version 4 versus IPv6. We talked about MAC addresses, domain names, what they represent, the fact that they point to a specific IP address, and then we talked about port numbers. Do well to review all the material set aside for this week, and take the quiz to gauge your knowledge of some of these concepts, and we'll talk again soon. Bye-bye.